Hey, what's up, class? We're going to look at section 7.1, exponential functions. Exponential functions. And this is lesson 7.1. That should be an S. Okay, and this is the beginning of our chapter, so it'll kind of be a little bit of a kind of brief compared to some of the other lessons. It won't be as long. Keep that in mind. So the form of an exponential function. An exponential function looks like this. Y equals AB to the x power. The x is an exponent. This is what's new here. The x is an exponent. Okay? The value of b, this is called the growth factor. B, let me go to a first. A is the initial value. Also the y-intercept. And b is the growth factor, or the decay factor, depending on what the value of b is. But in general, we call it the growth factor because decay is just inverse growth. So, if b is greater than 1, which it was in the little thing I showed you at the beginning of class, it is growth. And the graph we had at the beginning was going up. If b is less than 1 but greater than 0, so if b is between 0 and 1, we have decay. Okay, so let's do a couple quick little visuals of that. Growth would look like what I did at the beginning of class, a graph that goes up, up, and away. And decay, and this is just to get a general idea, I'm not being very specific here, is going down, 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 down. Now, when you look at exponential functions, they're always either increasing or decreasing. And this decay, it kind of looks like a slide, this decay graph, and it will always get lower, but never go beyond the x-axis. So it always gets closer and closer and closer to the x-axis, but it never actually touches it. Same thing over here. Let's get closer and closer and closer to the x-axis, but it will never touch it. So let's talk about graphing real quick. When we're graphing, we only really need to consider 2 points, then we kind of fake it using those templates above. So for graphing, let's see here. We're going to have 2 points. We're going to have the y-intercept, which is 0, a. If you put 0 into your function up there, let me go up to it real quick. If you put a 0 for x, anything to the 0 power is 1. So that will go away, just leaving you with a. And then we'll have the point 1. Well, what if we put in 1 for x? If I put in 1 for x here, b to the first power is just b, and I would have ab. So 1, ab. And using those 2 points, if it's a growth function, it'll look like growth. If it's a decay function, when you multiply by b, it'll get smaller. And then follow that general guide. It's going to get closer and closer to the x-axis, but never touch it. And this is just going to take off. This is going to grow very quickly, again, like what we talked about at the beginning of class. I'm going to give you one more formula, and then we'll be done. Another formula. Another formula. Which formula was it? It was the another one. Okay. This is another formula we use to model exponential growth. And what values do we plug in here? A is the principal. It is what you start with. When you get out a loan, the principal is the amount you take out, what you start with. R is the rate. And make your percents into decimals. R is the rate, and make your percentages into decimals. Move that decimal point 2 times. Okay, last one, T. Time. This will be in years. Because percentage rates are always given in years. And if something is compounded monthly, we have to do something a little differently, but that's generally it. And those are your notes for section 7.1, exponential growth.